Hello, and welcome to our presentations. It's Microservices with Kafka. This presentation, it's not a tutorial or in any way about microservices nor about Kafka, but it's more to share with you the challenges that we had with our project and how we address them, and also to challenge you in building on top of Kafka. So you can build it in any way you want that will serve your needs, or almost any way you want that will serve your needs. So this is the idea with what we want to do with this presentation. Of course, we have to do a short intro.
Hi, I'm Robert. I am an enthusiastic Java developer and father of 3, 2 girls and a boy. And I had the opportunity to work in large multinational companies like IBM, Einstein, and ING, where I had the opportunity to learn quite a lot about how to do high-performance software. And partially, this is what we achieved, and we will show you today. And
And I'm Dan Balescu. I like Java, what can I say? I worked in many companies, but the only thing in common was Java. Also had different roles, and again, Java related. So I could not escape Java, Java could not escape me. Also, I like to travel and to do some mountain biking. Also, I have a very nice family, I'm proud of it. But we do something very nice together, me and Robert, which is we work for ING in Bucharest. Bucharest, yeah, Romania, basically. I know it seems a bit small, smaller compared to Poland, but it's also an IT hub like Poland, and we really do like programming in Romania. That we like it that much that we have like around 6 of our GDP being produced with like 100,000 programmers. Of course, this is not the latest data, but maybe these numbers are changed by now. And compared to let's say agriculture, which Romania it was and it is very famous for, we have like 0.4 of GDP with almost 2 million people. So you see the weight of programming in Romania. Now, when we started this journey with the project that we have, we wanted what actually everybody wants these days. I mean, things like performance, fault tolerance, scalability, reliability. These are like, it's almost, we look at them like common sense these days. I mean, we could not imagine an application that could not handle this kind of requirements. However, to have these requirements in place, you need to, I think it starts with a good architecture. And for the scope of this presentation, we have chosen 2 architecture examples. And yeah. The first one is this. Yeah, it's actually not an architecture. This is Fiona. For those of you who have kids, I'm sure you know it. She's a princess, very beautiful one. Yeah, depends from the point of view. And she's priceless, and she's very high maintenance. So if I would have to make an analogy, I will look at Fiona like a monolithic application. Yeah, it seems something like that. Yes, monolithic. Do you use monolithic applications still? Anybody? I hope. Oh, okay. I'm sorry for you. Actually, it's not true, because I don't believe like we have a tool or a software, whatever it is, that will answer all of our needs. So maybe in this world somewhere, some company in some far, far away corner, they have some business case where a monolithic is the only way or the best way for their approach. So it may be. So I'm not saying that just monolithical are crap. They have some advantages. They have, for example, simplicity, consistency. You have a single technology stack, which, yes, it's useful, or it was, useful sometimes. But also have some very dark side. And, don't scale very well. This is something that we also encountered. I can give you an example. Actually, I cannot give you names, but still, we had in our company a web application, which was a monolithic web application, which was that large that could not, the application server where it was deployed to, could not handle adding more features. So we basically were stuck with those features, and we couldn't do more. So sometimes can be a pain in the ass to have a monolithic application. Also tight coupling, which it's not so good, we all know it. And definitely hard to move to new technologies, because it's not easy to, let's switch to a different technology with all the monolithic application. So, okay, what options do you have? Actually, Robert and I and the team also thought of it. And nothing came up, actually. We didn't come up with any idea. However, one day we were in a park, Robert and I, and we actually encountered this guy. Just walking like two guys in a park, and look, there is a donkey. And I don't know if you know his name, yes, it's Donkey, obvious, duh. And then we realized, like we had a aha moment, yes, this is what we want. We need a donkey for our development. And why a donkey? Because donkey is not expensive, right? There are so many donkeys compared to princesses, which there are not so many. They do one thing and one thing well. I think this donkey, it's eating shreds nerves. And I think this was something that we wanted, because it was highly scalable. We could, it was loosely coupled, which is exactly what we want. So we could handle different technology stacks, different applications, integrate them, and let's say work together as a whole. So why not? And then we took let's say an example. Since we are a bank, right? We work for ING, so I think the best way is to give you an example on the banking part. You have this account manager application, which is actually doing only some balance checks. So basically checks how much money are in your account. And let's say that I want to transfer some money from my account to, from Robert's account to my account. I think it's better this way. And what can we do to have this money in my wallet? Well, I definitely use this account manager. And yes, I need a core banking component. This component will actually move the money from one account to another account. But there must be some logic somewhere. Somebody needs to tell them what and how. So yes, we need another one. So as you can see, we have these three components, right, working together to deliver a service or a capability. In ING, actually, we have many capabilities to deliver. So that is why I think we have a lot of donkeys, which is very good. But these donkeys actually, as you can see, they work very well when they are combined. So when you tie them up together, then the real power comes out. If they take them in isolation, they won't do much. But this was the idea. And having these donkeys working together, it's quite a challenge, especially on the communication part. Because communication, even though we thought, okay, it's easy, we just send some, I don't know, directives from one component to another, actually when you have tons of them, and so complicated that it's not that easy. And the communication can become a bottleneck in this case. So in ING, yes, we have like a lot of, not only these donkeys, but a lot of them. But if I would, let's say, give you an example from a Uber-like company like Halo, which they offer a simple, easy to use, like everybody these days. They want to offer to their customers something very easy to use. However, they don't say that behind those easy UI that you have, there are tons of services working together to deliver that service, basically. For example, Halo, it's using around, I think, let me count, 450 services. Yes, I'm very good at math. Yes, but as you can see, many of them are talking to each other. There is a maze there. So communication is important. And if we take, for example, guys like Netflix or Twitter, they have quite a lot of microservices. So yes, many of them communicating, but how much actually they communicate? How many messages they exchange? Well, Twitter, it's about 500 million messages per day, which is okay. Netflix, like 700 billion, so we move scale, which is quite a lot, I think, to me. And then we have LinkedIn with 1.4 trillion messages per day. So I think this is definitely much more than my mother-in-law talks every day. And believe me, I actually worked on counting how much she talks. So they exchange a lot of messages. That's the idea. And the, let's say, the way that they handle these messages, yes, there are a lot of options on the market. However, the performance for those options were not as per the demand, actually. And the solution came up from this little guy, which is, you know the picture, it's Kafka guy. So if we take some, because definitely we wanted to understand a bit, okay, Kafka, but how much this Kafka guy can handle? Well, we had a look at the features that Kafka had. And definitely Kafka has loads of them. So we did a short comparison with ActiveMQ and RabbitMQ, which, let's say, were at that time our main the main competitors. And you can see, yes, both ActiveMQ and RabbitMQ offer this feature, but Kafka, no. Then JMS support. So yes, Kafka, again, no. The part of authentication authorization, again, no. At some time, we were wondering, does Kafka offer something? Because I mean, we didn't find it yet. Transactions, no. So what filtering of messages, of course, no. Yes, we found one, persistence. But then we look on the other side and say, oh, but those guys also are offering persistence. So, is there anything else out there? Then we came up with this, which is a short comparison in terms of performance. And then we also have, okay, that's the reason. So we have performance. So performance means the number of messages that are sent. And how much performance do we actually talk about? We have this comparison, which is like, I think LinkedIn published it like 5 years ago. And you can see you have a producer. This is what you have on the screen. You have a single producer, Kafka producer. And also you have the comparison between ActiveMQ producer and also RabbitMQ. And as you can see, it's sending like, I mean, this use case was send 10 million messages. Doesn't matter, with these 3 producers. And send them, let's say, in batches of 1 and batches of 50. As you know, it's more performance-wise not to send every time a message, but have a batch and then send it. But still, the comparison is good to show you because also you can see, so Kafka is handling a batch of 1, which is the most inefficient, and still if I'm counting again well, Kafka is sending like 50,000 messages, right, with one batch, in like 400,000 messages per second with batches of 50. So it's quite impressive when you talk about performance and compare Kafka with others. So, okay, but what about the consuming part? Because when you have a broker, definitely you have, right, two components. You have actually, without the broker itself, you have two, like producer and consuming. So on the consuming side, again, Kafka is quite far away from his competitors, actually. And it managed to consume like 22,000 messages per second, which is, again, quite impressive. So, okay, now I think it's clear. We understood why we should use Kafka. And this was performance. But we have a big drawback. Didn't have any feature. We didn't offer, feature. We didn't offer any feature except this performance. Okay, you have a broker, you have a consumer and a producer, but yeah, except the performance, they don't do nothing much. And then we had, of course, some business cases I will talk later on to fulfill. So, okay, what can we do? Since Kafka is open source, and I said, okay, now we can do something about it. And to let's say, emphasize a bit why we had to do something about it, we can give you one of the business cases, which was this microservice to microservice communication. So as you saw earlier on, we had communication like a very important thing to us, and we needed high performance communication. So that's why we had this case. We have a microservice trying to send the message to another microservice. So on the other hand, you have a producer, and on the other you have a consumer. This was one of the use cases. So one-to-one and unidirectional, but also you have bidirectional communication. So also we had to fulfill this use case, right? So the microservice B should have replied something to microservice A. One thing which I want to mention, it's not asynchronous. It's not synchronous. I mean, we shouldn't think about, when we talk about Kafka, we shouldn't think about synchronous. So everything here, it's asynchronous. So they shouldn't be waiting or blocking for some activity like microservice B waiting for something. Also, we have this use case, which is one-to-many. So yes, it was important to us to have a, let's say, multiple microservices consuming messages, the same message from a producer. So this was, again, something that we had to fulfill. And I think I'll let Robert move on the challenges that we had. Please.
Yes, so our first challenge is, well, you may ask if these are the features that we have to fulfill, then why we just don't use REST, right? Because with REST, you could do all of this, except the part with the asynchronous thing. But it will do exactly the same. It will send messages unidirectional way, bidirectional way, or even making a simple notification. So then let's assume we have a system composed of two microservices. Service A, which will send the message, and service B, which will receive that message and doing some processing and later on to store it in a database. So first of all, you will see two issues with this. First of all is that, well, actually even before that, this communication is synchronous. But beside that, you see the other issue is that actually service A has to know exactly where service B is, and its response time is dependent on service B's response time. So its performance is directly related to the performance of service B. Also, it cannot answer without first having the response, of course, from B. And it's also dependent on the uptime of service B, which means that its uptime is dependent on service B. Well, and what we can tell is that a system is as weak as its weakest service. But before that, we can raise some other questions, like how often does service B fails? How often it's down for maintenance? What is its peak performance? And all these can raise you some questions that in some cases might be difficult to answer. So let's see then how this would compare with having Kafka instead. Well, having Kafka, we have quite a different story. First of all, a Kafka topic has a trick up its sleeve. It's persistent by default. So this means that system A has to make sure that the message will be delivered to Kafka, and eventually system B will take that message and will do its processing and everything else that needs to do. So then we see that, well, first of all, this is asynchronous. Second of all, we will see that actually service A doesn't have to know where service B actually is there. So there is no much coupling on it. And if we go further, then let's see how we do if we are talking about scaling this. So let's suppose that at some point, service B is not fast enough. So what you will do, you most probably start a new service B, right? And this is all fine until a certain point, is that actually you have to make service A to know about the additional services. Most of you, what will do, will add most probably a load balancer in front of it, which is still working, but this means still that you have to make service A to know about that load balancer. Even more, you have to do additional monitoring on your services for uptime, for responsiveness, so that the load balancer actually could do its balancing. And if we go even further, we can also add another service G, which at some point might need exactly the same message. So this would need that, again, service A now will have to know also about service G, so that it could deliver the message to that service as well. And if we are going with the analogy, we can see that if this we have to scale it, we quite have some issues there. Of course, there are already some tools that can help you in doing this. And let's see what would be if we would use Kafka instead. Well, again, Kafka has another trick up in its sleeves, is that a topic can have almost as many consumers as you want. Of course, it needs to be tuned. But from service A's point of view, it has to do nothing. It will still deliver the messages to the same topic. Well, if you are doing multiple service B services in parallel, you have to put them in the same consumer group, and then Kafka will load balance for you out of the box. If you need another service like service G to consume exactly the same message, well, you hook it up to the same consumer without any other change in your infrastructure. So all these shows that actually Kafka would be a better choice in using compared with Spring, with REST. Oops.
Yeah, it's.
You can use Kafka with Spring as well, by the way. They have a pretty good integration with it. And then
He's not working for Pivotal, but it's okay.
But having chosen Kafka, actually we had the opportunity to implement an additional use case, which would be the logging part. As we have quite a lot of microservices, all of them are logging quite a lot. And well, being a bank, they need to have these logs centralized to store it for years even. And this would make them difficult to do it in traditional way through files. They do it like that until now. But this, of course, gives them the opportunity to do even more than that. Is that, well, if you have an application that is working with some other systems, who knows if that system is down? Not the guys that actually are monitoring it, is the application that actually tries to use that service to do something with it. So you will be the first to observe that actually you have an issue and can trigger an alarm. So this opened up the possibility to do near real-time monitoring and to monitor your systems by these alarms. And they had pretty good results having this. In a matter of 1 or 1.5 seconds, they already know if the system is down. Good. So for that, first we need to start somewhere. So we could have used directly the native Kafka API, but this wouldn't allow us to actually implement and add all the features that were needed. Because, well, most of the users that had to use Kafka, they were quite used to GMS, having it before. So they wanted similar features to have there. And we had to open this opportunity to actually be able to do this, to not have all of them to implement the same things in different applications all over. So we started by making a producer. We tried to make it as simple as possible, and this is quite as simple as we could think of. So you have only a producer factory that is creating you a producer that will send messages to a given topic, and then this producer have a method that's called send. So it's pretty easy. The message here that you will see, it's more like a message with having a payload and some key value pairs. It's pretty similar to other messaging systems that they have as their generic message type. Its architecture, it's a bit more complicated than you see here, because actually we have an API part for clients that want to use our library, and we have also an SPI for those that actually want to extend with further features our application, our library. So but simplistically, it's more like this. We have a producer factory, which in the background uses, of course, the native Kafka Producer API. You can, of course, tune your producer, the native producer in the background, with the native properties as well. We treat the security part separately because, well, security is quite important, and especially for the certificates, their location, the passwords that you have are very strictly monitored, so we are treating them differently. And of course, from this, we can produce the producer that looks more like a wrapper, but it's a wrapper that opens you the opportunity to implement all the features that you will need. So now that we have a producer, actually, we were able to implement the logging part. And on the left side, you can see actually the traditional way of logging by using a file appender, which will produce a log file. Then we had some applications that log/forwarders, we are saying to them, that will monitor these log files and will forward those messages to the elk stack, and later on can be processed by other systems as well. On the right side, you see the implementation done throughout our producer, and we are then producing messages to Kafka, the logging messages through Kafka. Okay, so as we have a producer part, of course, we needed also to be able to consume those messages. And our philosophy was more or less the same, to be as simple as possible. So again, you have a consumer factory. From it, you create a consumer. And then to that consumer, you are registering a receiver handler to it. And you are processing the message already. Its architecture, again, it's pretty similar with the one of the producer. Again, this is a simplistic version. Here, again, we have an API part and an SPI part. But I don't want to bother you with that anymore. So let's see what kind of features we enabled us to do. So our first feature, we are calling it serialize. What we did actually is that opened up the opportunity that when we want to send a message, before that, to be able to do some transformation on those messages, and even more to do some custom serialization on it. By transformation, I mean informations like, I don't know, inserting the user ID that currently it's doing the transaction, or inserting the timestamp when this message was triggered, to insert maybe the host name from which this message was originated. And even more. By serialization, we were meaning by, I don't know, encode this message as a JSON, encode it as an XML, or encode it, I don't know, with Google Protobuf maybe, if this is your need. And actually, even more, we have the opportunity to also encrypt the information before sending. And of course, on the consuming part, you have the reverse of it. Good. So another feature that we saw also in that table before, that we didn't have filtering. And actually, we implemented filtering in two ways. One of it was doing another microservice. Here is the one called filter. It's actually a microservice that we built, which simply listens to one topic, and based on some metadata, will filter out that information to be sent to another topic or not. You may ask why actually we would do that if it's Kafka, and you could hook anyone there. Well, we have some strange requirements like that given topics are allowed to be accessed only by a little amount of applications, and no one else is allowed to actually consume from there because the data is too sensitive to allow that everyone to use it. But there are those few amount of applications that actually want to do processing with it. They can use it like this. And well, their power, it's not necessarily by using it individually, it's by using it together with other features. Again, we have another transformer, another way of doing transformation. It's besides how I showed the two slides before. So here again, we have the same situation. We are listening to one topic. Based on some metadata, we do some transformation of this message and sending to another topic. Actually, this is something that also the monitoring application is doing, because from their point of view, a log message is just an event like any other message. And again, we have this forward and dispatch. Which pretty similar. It's more like reading the message from a topic, and based, of course, again on some metadata, will dispatch and forward to other topics. And as I said, all of these individually are not doing too much, but when you combine them with our donkeys, then you start to get quite interesting features and applications to implement. Here is another cool feature which we could do because we used Kafka. What this feature does, this replay, feature is that, as you may know, a Kafka topic it's persistent. It's persisting the data on the hard disk. And actually, that data, it's available for you for a given period of time, which opens you the opportunity to do some hacks on it. And why actually we need this is, well, how many of you actually here are developers? Quite a few. How many of you actually develop bugs as well? I like this. We are doing the same. So having microservices, of course, we have the opportunity to update them more often than before. And of course, from time to time, we are developing some bugs with the features as well. Actually, a bug, it's a good feature. Or a feature, it's a bug. Anyway, so the idea is that if we realize that actually we did process a message in a wrong way, then we have the opportunity to actually reprocess those messages. And what this functionality does is that it will go on the topic message by message. It will check if indeed that message was one that was processed in a wrong way, and then gives us the opportunity to resend it again and reprocess it in the correct way. Okay, so, well, these are not all the features. It are the features that we are presenting now. We have many other features that opened up the opportunity for us, like having different versions of Kafka to work with, and many more. And you may say, okay, but these definitely, they have some costs. And indeed, they have. Actually, what my colleague didn't mention was that in 2014 or 15, the guys that developed Kafka, they published a paper where they show you how to send more than 2 million messages per second via Kafka with 4 or 5 simple hardware, simple, cheap desktops. So it's pretty easy to send an amazing number of messages. And we wanted to know, okay, this overhead that we put on it, it will make us to be still able to send that many messages or not. So we micro-benchmarked. We micro-benchmarked the amount of processing that we are doing from the moment you call the send method in the producer until the moment we would have actually sent it to the native Kafka producer. So the amount that we are wasting by processing, by doing our additional logic on it. And here you can see messages of different sizes and different payloads. And what is important is that most of our messages are around 500 bytes. And with 500 bytes, you could send about 2.7 million messages per second. And in some special cases, when you want to do even more, you can actually do, of course, by reducing the size of the message. So if you want more performance, then you will have to drop some of your timestamps or server names and things like that. But you can send that essential data. We were able to achieve more than 9 million messages per second. So you can do it almost at the same rate as Kafka is doing, because when we are having all these and sending to Kafka, of course, we weren't able to get that 2 million messages, but we were pretty close to that. On logging part, we were able to send only 224,000 messages per second, and this was due to the requirements that we had. Actually, these messages are quite huge, and they are containing a lot of info. And beside that, they are also having a digital signature made for each individual message. So this cost us quite a lot. But we were still able to process 220,000 messages per second with one producer. OK, so we saw that actually we have Kafka, which is very performant, not too many features. We have other competitors that have quite a lot of features, not that many performance. So by adding some features on top of it, you can actually make your Kafka to be almost that performant as the vanilla Kafka and almost as feature-rich as the competitors. And this would be more or less what we did and what we wanted to show you. And we would want to embrace you to do the same, because it's worth it. You learn a lot by doing this, and your boss will definitely pay you an attention by doing that.
This is questionable. No.
Thank you for being with us.